Hello students, let us first revise the concepts which we have discussed in yesterday's class, and later on we can start with today's concepts, right. So, this was the table which we discussed yesterday. So, the function and its corresponding derivative, right. See, you will have to make a list of all these, right. So, you should remember them. So, these are few things which we will be using quite frequently. So, if not all the functions, at least few of them, like this x power n is something which is very important, sin x, cos x, constants. So, these are all things which you will be using quite frequently. So, make a table out of this and make sure that you are separately looking at it at least once every day for the next 1 week or so, so that you do not forget this, clear. So, we have seen this, we have derived the derivatives for few of these. So, we have derived the derivative for x square and we have used the first principle, right, and so using that itself we will be deriving all these expressions. Okay. So, even in this case also we have derived the derivative of tan x. You remember that we have considered tan x as sin x by cos x and we used u by v rule, correct. So, using that we got secant square x. I think we derived cosecant x, if I guess, or secant x. I think we derived for secant x which was taken as 1 by cos x, correct, and we derived the derivative for this. So, similarly I have given you the result for cosecant x and cot x as well. So, we have not derived the results for these two yesterday. So, I want you to complete the derivation of calculation of derivatives for these two functions. I guess you are aware of how to do that, right. Cosecant x can be taken as 1 by sin x and you can use u by v rule, correct, and cot x can be taken as cos x by sin x and once again u by v rule. So, these are the results which you will be getting, right. So, please derive these in your notes. I want to see these two results in your notes, clear. Then, so if you observe closely, if you look at these trigonometric functions, these 6 functions which I have written and their corresponding derivatives which are over here. So, there is one pattern which you will observe, right. So, we have negative sign for 3 of them, the derivatives are negative for 3 of those, and if you observe closely, so for all those trigonometric functions which start with c, cos is starting with c, cosecant is starting with c and cot is starting with c. So, all those 3 which are starting with c will have a negative sign for their derivative. So, you can keep in mind like that, you will not get confused, clear. Cos will have negative derivative, cosecant will have a negative derivative and cot will have negative derivative. All the remaining 3 will have positive derivatives, clear. So, that is the idea, and similarly e power x will have e power x itself as the derivative, log x to the base e which is also called as ln x, ln x is how we pronounce it. So, ln x, the derivative of that is 1 by x, clear. So, these are some expressions which you will have to keep in mind, right. So, as I told you, please write them separately and stick that paper somewhere wherever you are studying and make sure that you see it at least once every day for the next week or so, clear. Okay. So, let us find the derivatives of these 4 functions which we have here, right, and then we will start with the next concept. Okay, we will first solve for the first function. So, obviously we should be using u by v rule, right. So, the value of y is given as x square plus 1 divided by x minus 1. So, if I have to find the derivative, you know that we can write y dash is equal to, if this is taken as u, the numerator is taken as u and the denominator is taken as v. So, what is the expression we would be getting? In the denominator we will be writing v square and v u dash minus u v dash, clear. So, if I substitute the values, so in the denominator I will be getting v square which is x minus 1 whole square and v into u dash. So, I will just write it first. So, x minus 1 into u dash means derivative of x square plus 1. So, I will first write it as x square plus 1 dash minus u is the first function which is x square plus 1, correct, into v dash. V dash means this one. So, x minus 1 dash. So, now you know how to find the derivative of this, right? Derivative of this function and derivative of this function. So, let us substitute the values. So, x minus 1 into what is the derivative of x square plus 1? I can individually differentiate and add them. So, what is the derivative of x square? 2x, and derivative of 1, which is a constant, will be 0, correct? Minus, here this is a function which I can write directly, x square plus 1 into derivative of x minus 1 dash, derivative of x minus 1. What is the derivative of x? 1, and this, the derivative is 0. So, into 1 divided by x minus 1 whole square. Clear? So, rest is just simplification. I guess you can complete that, or we will quickly do this. 2x into x is 2x square. So, I would be getting, here we have 2x square and minus x square. So, x square, and minus 1 into 2x is minus 2x divided by x minus 1 whole square. So, that is it, students. So, that is how we will be using u by v rule. I hope you remember that. Now, similarly, let us quickly do for the other 2 cases, other 3 cases as well. So, if I see this second function, f of x or y is given as e power x into sin x. So, even in this scenario, I will consider this as the first function u, this as the second function v. You know the expression for derivative of y, we can write it as u v dash plus v u dash, correct. So, just substitute that, u is e power x into this one. I will directly write the result now, you know this. So, derivative of sin x is cos x plus v into, v means sin x, into derivative of the first function. What is the derivative of e power x? E power x itself. So, into e power x. So, that is it. The final expression which you get would be e power x into sin x plus cos x, right. So, we used u v rule, product rule. Okay. Now, the third one, once again u v rule, product of 2 different functions, correct. So, I will directly write it. By now, you should be aware of how to do it, clear. I will directly write it, first function into derivative of second, correct. So, first function is 2x cube plus 5x into, what is the derivative of tan x? We have just seen that it is secant square x. So, into secant square x plus, now second function into derivative of first function. So, that would be tan x into derivative of 2x cube plus 5x. So, what is the derivative of 2x cube plus 5x? Let us do it separately and then we will directly substitute it here, clear. So, if I have a function 2x cube plus 5x, if I have to differentiate it, you know how to differentiate this? I can write it as 2 into derivative of x cube would be 3 into x power 3 minus 1, which is 3x square, correct, plus this is x power 1, you know that the derivative of x power 1 is 1 itself, right. So, or you can understand this as 5 into 1 goes to the front and you will get x power 1 minus 1, which is x power 0, and x power 0 is 1, right. So, if I simplify this, 6x square plus here we have 5, that is it. So, I will substitute that here, 6x square plus 5, clear. So, we leave it like that, you do not have to simplify, we are just learning how to differentiate, right. The answer, the final result is not of much importance. So, once we are doing it correctly, so simplification is not required. Okay. Then fourth one, the last one. So, here we have 3 different expressions added and subtracted. You know how to deal with such cases, we will differentiate each one individually and then perform the operation. So, let us first simplify this. You know that 5 by x power 4 can be written as 5 into x power minus 4, this is normal x cube itself, minus ln x. So, I would suggest whenever you come across expressions where powers are in the denominator, first write it separately in the numerator by taking a negative sign like this, and then you apply the expression. Clear? Okay. Now, let us differentiate it. So, if this is y, then y dash can be written as, so first differentiating this, I would get 5 into minus 4 comes to the front. So, minus 4 into x power. Now, I should decrease the power by 1, right. So, minus 4 minus 1. So, this would be the first expression plus, now the second expression, x cube, we all know, we have been doing it many times. I will directly write it as 3x square, correct, and minus the derivative of ln x is 1 by x. So, that is it. If you want, you can simplify this expression and write it down. So, minus 20 x power minus 5 plus 3x square minus 1 by x. So, that would be the result eventually. So, that is what we discussed in last class. That is how we apply derivatives when we have sum, product or division of different functions. Clear? So, now let us learn a different concept. So, students, now we will discuss about a concept called chain rule of differentiation. So, this is something which we will apply whenever we need to differentiate a function which is in the form of a function inside another function. Clear? So, let me just give you an example. So, this idea is basically called as chain rule for differentiation basically, right. So, let us consider a case where we have a function y which is given as sin x square plus 3. Now, so till now we have not discussed about how to differentiate this function. We know what is the derivative of sin x, we know the derivative of x square, we know the derivative of 3, but we do not know the derivative of sin of x plus 3. You understand what I am saying? I know the derivative of this function, I know the derivative of sin x function, right. Individually I know the derivatives if they are in the basic form. So, this is the basic form, right. But if this is a function which is inside another sine function, we are now looking at how to differentiate it, right. So, we know that d by dx of sin x is cos x, and we have discussed also that it's instead of this being x, it could be any other variable also. If I write it as d by dt of sin t, that would be cos t, or if it is d by dt or d by dz of sin z, we can understand it as cos z. So, it could be anything here, right. It could be theta. So, d by d theta of sin theta is cos theta, or it could be anything. I can place anything here. So, if as long as this is sine of something, and if I am differentiating that with respect to the same something, so whatever that is present here, if the same thing is present here, then we know how to differentiate it, correct. So, let's call this as a circle. So, d by d circle of sine circle will be cos circle. You can view it as anything, you can call it as O, you can call it as circle, you name it. So, as long as you have sine of something, and if you have the same something here, then we know the derivative of that. Clear? So, if you now look at this, to differentiate this expression, we will be using something called chain rule. And to understand chain rule, what I will do is I will take someone's help now, and I am going to take the help of this person, right. So, this is the person who is now going to help us. So, he is called Smiley, right, you all know that. So, I will be using this person, and he will help us now in differentiating this expression. So, observe closely. So, what I will do is whatever is inside the bracket, I will consider him as Smiley, right. So, I am not looking at this x square plus 3 now, I do not know what it is, just like I have told you now. I know if I have sine of something, if I am differentiating that with something, I know the method of how to differentiate it. It does not matter whether there is x there, t there, z there, circle there or smiley there. So, let me write smiley also. d by d smiley of sin smiley, right. So, what would be the value of this? This would be cos smiley, right. So, in the same manner, what I am going to do now is I am going to consider whatever is present inside this as smiley. So, I need to find dy by dx. So, I need to differentiate this with respect to x, but what I know is once I consider this as the smiley, I know how to differentiate this with respect to smiley, right. I do not know how to differentiate it with respect to x, but I know how to differentiate sin smiley with respect to smiley. That is what we have written there. So, what I am going to do now is I will just manipulate this expression. So, I will write it as dy by, so observe closely, I am just separating this dx to the other side, and what I am going to do is I am going to put smiley here, d smiley here and d smiley here. Understood what I have done? So, basically I have created a chain here. So, this is the chain which I have created. So, because I cannot directly calculate the value of dy by dx, so to calculate dy by dx, what I have done? What have I done? I have created dy by d smiley. I know how to calculate dy by d smiley, and then I know how to differentiate smiley with respect to x. What is our smiley here? So, in this particular case, our smiley will be equal to x square plus 3. Understood? So, that is the idea. So, when I replace this with smiley, I know how to differentiate it with respect to smiley, and then I know how to differentiate the smiley also with respect to x, right. So, that is the method I will be using. So, instead of directly calculating dy by dx, what am I going to do? I am going to differentiate this with respect to smiley, considering that this is the smiley, and then I will differentiate smiley with respect to x. So, that is the idea. So, now what is dy by d smiley? We know. So, d by d smiley of sin smiley, this becomes sin smiley. So, the answer for this would be cos smiley, clear, multiplied by d smiley by dx. So, now I need to differentiate this with respect to x. You know how to do that? What is the derivative of this with respect to x? That we can do. So, derivative of x square will be 2x and derivative of 3 will be 0. Clear? So, that is the idea, and you can substitute the value of smiley back into the expression and you will get the value as cos x square plus 3 into 2x. So, that is it. So, by understanding that this is some other term which is smiley, in this case we have eventually differentiated that expression. So, observe closely, what we have done is we have found the value of this, we have found the value of this, and then we are multiplying the two to find the actual result that we need, right. So, that is the basic idea. So, if you observe closely the concept that I have used here, because this is a complex function, why I am saying it is complex? Because there is a function inside another sine function, clear. I know how to differentiate a sine function, I know how to differentiate an x square plus 3 function, but if one is inside the other, then this is how we will be understanding it. We will be thinking of some other extra term, we will be differentiating. So, I will be looking at it as just a smiley, I will just differentiate this with respect to smiley, and then I will differentiate whatever that smiley is with respect to x. Is that clear, students? So, that is the method which we will be using. So, keep in mind. So, that is the idea. So, let us see one more example, then it will be clear for us, right. So, let us consider this time y is equal to, let us say, square root of 2x plus 5, clear. So, square root of 2x plus 5. So, this case is once again a function inside a function. How is it so? Because I know how to differentiate 2x plus 5, I know how to differentiate root x, but I do not know how to differentiate root of 2x plus 5, clear. So, 2x plus 5 is inside a square root function. Do you understand what I am saying? So, how do we differentiate it? So, dy by dx is equal to, so let us bring back the smiley once again, let us take help of this smiley, right. So, now I am just looking at smiley. So, root over smiley is our function, right. So, dy by dx can be understood as, first I will differentiate the function with respect to smiley, right, and then I will differentiate smiley with respect to x. See, remember students, I am just using this term for us to initially understand. Eventually, I will not be writing these steps. Even you should not be using this smiley each and every time when you are differentiating such things. But initially, when we are understanding how to do it, this will definitely help. Clear? So, initially do this. Once you do enough practice, some 10 to 15 cases, then you will eventually understand that we do not need smiley. We can do, we have our brain to do it, we have our mind to do this particular calculation, but initially while learning let us use smiley, right. So, that is the idea. So, dy by d smiley into d smiley by dx. So, what I am basically doing is, first I am simplifying this expression. I do not want to look at what is inside, I will do that later. So, whatever is here, first I will consider that as root of something. Now, I will differentiate that with something, and then I will differentiate something with respect to x, and that something is smiley here, right. Okay. So, now do not look here. So, this is root smiley. So, you know what is the derivative of root x. So, you know this expression, what is the value of d by dx of root x. So, if you do not know, let us differentiate it. So, this is nothing but d by dx of x power 1 by 2, correct, right. So, if I differentiate that, you know, I can use x power n formula, 1 by 2 comes to the front into x power 1 by 2 minus 1, correct. So, which gives me 1 by 2 into x power minus 1 by 2. So, which is basically 1 by 2 into, this is, what is this? This is 1 by root x, correct. So, 1 by 2 root x. So, this is the result. So, the differentiation of root x is 1 by 2 root x. So, in the same manner, can I understand that should it be x all the time? I can use any expression there. So, if it is d by d z of root z, then it will be 1 by 2 root z, correct. If I use smiley, then d by d smiley of root smiley is equal to 1 by 2 root smiley, right. So, I will use the same concept. So, I will not look at what is inside, I will consider that as my smiley, right. So, I have root smiley, I will differentiate that with smiley, right. When I differentiate root smiley with smiley, I just got the result. So, I will be getting 1 by 2 root smiley. So, let us write the value of smiley. So, 2x plus 5. So, the first part is done. Now, what should be done? Once I differentiate it with respect to smiley, is it over? No. Now, I have to differentiate my smiley with respect to x, clear. So, this is the chain which we have created there. So, first whatever we have function, I will differentiate it with smiley, then I will differentiate smiley with respect to x. I hope you understand this. So, into what is the differentiation of smiley with respect to x, which means I have to differentiate 2x plus 5, which is the smiley in this case, with respect to x. I hope I can write the result directly. Now, you know how to differentiate 2x plus 5. So, derivative of 2x is 2, derivative of 5 is 0. So, 2 plus 0. So, that is it. Here this will be 2, 2 and 2 will get cancelled, and the final result I would get is 1 by root over 2x plus 5. So, that should be the answer. Clear, students? So, whenever you come across cases like this, so till now we have used smileys. So, let us do 1 or 2 cases also using analysis like this, but eventually we are not going to use this. We are going to do all the calculations in our mind. Clear? Even you should practice in the same way. So, this is only for understanding initially. So, initially you can write steps like this and then think of it like this, but as I told you, once we have enough practice, remove that, do everything in your mind. Clear? Students, let us see a few more examples on chain rule. So, 3 cases are given to us, let us do them one by one. So, first this one, third one. So, they have given y is equal to cos of x square plus 5x plus 1 by x. So, remember I'll use smiley for one or two cases and then I'll stop using smiley. We'll have to do everything in our mind. Okay. So, this is our smiley, right. So, smiley. So, I have cos smiley. So, first I'll differentiate that with respect to smiley and then smiley with respect to x. So, dy by dx is equal to dy by d smiley, right, into d smiley by dx, correct. So, you know that once I understand this as smiley, we have cos smiley. When I differentiate it with respect to x, I will be getting what is differentiation of cos of anything with respect to the same thing, you will be getting minus sine function, correct. So, when I do this, I will be getting minus sine smiley. So, let me write the value of smiley, I already have that here. So, x square plus 5x plus 1 by x, correct. So, the first part is done. Now, the second part is to differentiate whatever was inside with respect to x, correct. So, now when I differentiate this with respect to x, so I will write the expressions directly. So, derivative of x square is 2x, derivative of 5x is 5, correct, 5 into derivative of x is 1 plus, so derivative of 1 by x. So, x 1 by x can be understood as x power minus 1, correct. So, when I differentiate this, minus 1 comes to the front, x power minus 1, right. Okay, let me write it, minus 1 into x power minus 1 minus 1. So, that is the expression which we get. So, simplifying this, I would be getting minus sine x square plus 5x plus 1 by x into what is this? This becomes minus x power minus 2. X power minus 2 means 1 by x square. So, 2x plus 5 minus 1 by x square. So, that is it, right. So, that is how we use chain rule. So, let us complete the other questions as well. Okay. So, now next one is sine cube x. So, fourth one is sine cube x. Okay. Now, this one you should be little bit careful. So, first understand what is the function that they have given. So, y is equal to sine cube x. What does that mean? We know that this can be understood as sine x whole cube, right, correct. So, sine x whole cube is what we represent as sine cube x. So, whatever function is given to you, once you identified that it is in the form of function inside a function, then bring it into that basic function form. Basic function in the sense we have written the table, right. So, the earlier table. So, it should be in that form. So, those functions are the basic functions, clear. So, whatever is given to you, try to bring it into that form. So, now we have this in that form. So, we have a sin x function which is inside an x cubed function, correct. Okay. So, I will assume this term inside the bracket as my smiley this time. So, this is my smiley. So, I have smiley cube. So, let me write it, dy by dx is equal to dy by d smiley into d smiley by dx, correct. So, let us substitute the values now. So, what is our initial function? So, this is smiley cube, right. What is the derivative of smiley cube with respect to smiley? You know that it is just in the form of x cube with respect to x, correct. So, what is the value I will be getting? 3 comes to the front, smiley power 3 minus 1, correct. So, what I have done here is I am understanding this as smiley cube, right. So, first I am differentiating that with respect to smiley, then smiley with respect to x. So, 3 what is okay, let us do the next part. So, now I have to differentiate smiley with respect to x. So, this is the one, if I differentiate this with respect to x, you know the result, right. So, it is cos x. So, that is it. So, that is our answer. So, substitute the value of smiley back. So, I would be getting 3 smiley is sin x, so sin x whole square, which is sin square x, right, into cos x. So that's it, that would be the answer, right. Okay, now I won't use the smiley, I'll throw it away. So let's do the next question without that. Let us think in our own minds. So here next one which is given to us is e power 5x plus 1. So y is equal to e power 5x plus 1. So remember once again how we should think. So we know the derivative of e power x, clear. So in this particular case I need to find dy by dx. So what you will do is create a chain in your mind. What is the chain you are going to do? I know the derivative of e power x. So I know the derivative of e power x. What is the derivative of e power x with respect to x? That would be what? E power x itself. But here I have e power 5x plus 1. So what you are going to do is, I know how to differentiate e power something with the same something. So what I am going to do is, I am going to differentiate this with 5x plus 1, clear? Then I will differentiate 5x plus 1 with respect to x. That is what is the chain here. So first, instead of differentiating this directly with x, you differentiate this with respect to 5x plus 1. When I do that, I get e power, the same expression. So what I am saying is, just like d by dx of e power x is e power x, can I say d by d of 5x plus 1 e power 5x plus 1 will also be equal to e power 5x plus 1, correct? So it does not matter what this x is, right? It can be anything. In this case it is 5x plus 1, right? So d by d of 5x plus 1 of e power 5x plus 1 will be e power 5x plus 1, right? So I'll listen carefully. What I am going to do now is differentiate this with respect to 5x plus 1, and then I'll differentiate 5x plus 1 with respect to x, clear? Okay. When I differentiate this with respect to 5x plus 1, I'll get the same expression, right, which is e power 5x plus 1 itself. Now what should I do? I should differentiate 5x plus 1 with respect to x. And you know how to differentiate 5x plus 1 with respect to x? How do we do that? Differentiation of 5x is 5, 1 is 0. So simplifying this will give me 5 times e power 5x plus 1, clear? So that is the idea. Okay, so even if you are not still very much sure about directly solving it, you use smileys for a while, clear? At least for few more examples. You keep replacing them with smileys till you get that confidence, and then once you have done that, once you get the idea of how to approach such cases, you can remove that. You can remove the smiley and you can do it on your own, clear? So that is the idea. So students, now let us see one common mistake which most of us would be doing, right? So for example, if they give us a function y is equal to sin x or sin, let us say sin 2x. So if the function given to you is something like this, y is equal to sin of, let us say 2x plus 31, something like this. So you know that it is a function inside a function, and you know that you can use the chain rule to find the derivative of this. But when it comes to cases like this, you will think that if, for example, let us say you try to calculate the derivative of that, try to calculate the derivative of sin 2x, and we will see what the result is. So pause for a while and calculate the derivative of sin 2x, and we will see what the answer for that is. So y is equal to sin 2x. When I consider this, what you will do is, we know that derivative of sin x, so d by dx of sin x is cos x. So you will think that this is just 2x. So when I differentiate sin x, I will get cos x. So when I differentiate sin 2x, I will get cos 2x. So and you will directly write the answer as cos 2x. But this is wrong. So this is wrong. So as I told you, whatever is inside the function, when you differentiate this with respect to the same thing, then you will get that expression, correct? So what I am trying to say is, in this case, if you differentiate sin 2x, d of sin 2x with respect to 2x, then you will get cos 2x. I hope you understand this. The differentiation of sin 2x with respect to 2x is cos 2x. Is that clear? So, whatever is here, if the same thing is here, then we get cos x or cos of that thing. Is that clear? But here we need to differentiate this with respect to x. So, the idea is once again the same, you have to apply chain rule. So, the derivative of this can be understood as dy by dx is equal to, remember, it does not matter what is inside the sine function. I will first differentiate that with respect to the same thing. Whatever is inside, I will differentiate it with respect to that thing itself. So, when you differentiate sine of this thing with respect to the same thing, I will get cos of that thing, correct, which is 2x. Now, what should I do? Now, I should differentiate that thing with respect to x. So, now when I differentiate this thing with respect to x, what is the derivative of 2x with respect to x? 2. So, that should be the answer for this. So, this would be 2 cos 2x, clear. So, this is a mistake which most of you would be committing, maybe in a hurry or maybe in some overconfidence, right. So, do not make that mistake. So, observe the question given to you closely, right, and try to apply that. So, whenever you have something which is not in the basic form, the chances are that you should be definitely applying chain rule, clear. So, just assume that this is something, differentiate that with something, then differentiate something with respect to x. So, that is the idea. So, there you are connecting a link between the first derivative and the second derivative, right. So, that is why we call it as a chain rule, right. Okay, we will see another example. So, this time let us take a little bit complicated one. Let us include chain rule with the earlier concepts which we have discussed, right. So, which question was this? I think 6. So, now 7. Okay. So, this time y is equal to x square into let us take sine, or let us not take sine all the time, let us take tan this time, tan x square or 4x cube minus 2x plus 1. Okay. So, that is the question, right. Now, we need to differentiate this. See, do not worry, we will not be getting such complicated differentiations in our physics, but now that we have started differentiation, let us at least get some basic ideas about differentiation, right. So, let us understand the ideas and then we can leave it. We are not going to apply this in each and every concept in physics, but it gives us a better understanding of how to deal with that cases, right. So, let us see. So, obviously, you can see that this is a product of two functions, this is one function, this is another function, and if you look at this, this one is a function inside a function, right. Okay. So, let us understand this as u, this as v. We know that y can be written as uv dash plus vu dash, correct. So, let me substitute the values. So, I would be getting dy by dx is equal to u is x square. Now, this is where you should be careful. Now, I should differentiate this function. Okay. Let us get back to that later. I will just leave it there. I am not going to substitute anything there. Let me just write down the full expression first, plus v is this. I will directly write that v, which is tan 4x cube minus 2x plus 1 into u dash. You know how to differentiate the first function, derivative of x square with respect to x is 2x. So, into 2x, clear. Okay. Now, I need to substitute this, correct. So, what I have done is just product rule, and when I applied product rule, I am getting derivative of this function. So, I will calculate the derivative of that function separately by using the chain rule which we have discussed, that is it. So, it is not that complicated, it is just a combination of two concepts which we have discussed, that is all. So, let us do that separately. This is the function which I have, right. So, let us represent it with some other variable, because we already used y, let us represent some other variable. So, let us call it as z. So, z is equal to tan 4x cube minus 2x plus 1. And now I need to find out the differentiation of this with respect to x. Clear? So, which means I need to find the value of dz by dx. Now, observe closely. We know the basic function of tan, the derivative of tan function, tan x will be secant square x, correct? Okay. Now, I know the tan function's derivative, so I won't worry about what is inside. Please observe how I am thinking. I don't want to see what is inside, I won't even look at what is inside. So, I will close it, clear, I don't know what is inside. So, I have tan of something, I don't know what it is. So, what I am going to do is, I am going to differentiate tan of something with something, clear, that is the first step. Tan of something, differentiate with something. So, what do we get? We get secant square something, that is it, right, because d by dx of tan x is secant square x, right, which means d by d something of tan something is also equal to secant square something. Do you understand what I am saying? So, I am just replacing x with something, that is it. Okay. So, I am not showing you what is inside, although you know, but let us think that way. So, tan of something, what am I going to do? What is my first step? Differentiate that with something, whatever is inside that. What do I get when I do that? I get secant square something, and that is 4x cube minus 2x plus 1. Is it done now? No. Now, I have to differentiate whatever is that term inside, that something with x. So, now when I differentiate this with respect to x, what do I get? So, differentiation of 4x cube, let me write it, 4 into differentiation of x cube is 3 into x power 3 minus 1, which is 2, minus differentiation of 2x is 2, differentiation of 1, which is a constant, is 0. That is it, we have done it. So, finally, I will be left with secant square 4x cube minus 2x plus 1 into 12x square minus 2. So, that should be the answer, students, and you can substitute this result into the gap which we left there, right. So, that is the idea. So, please observe how we have developed this concept. Initially, I used that smiley, right, to think about this idea. Later on, I have just closed that function so that I do not see that, and I was just calling it as something. And this way, if you progress, if you keep practicing, you will eventually look at the function and you will be able to write the expression. So, you should reach there, clear. It will take some practice. So, you will do enough practice on this, you will be given enough number of questions to practice, right. Once you are done, you have completed that, you will definitely be very comfortable with doing these calculations, right. Students, we will see one last question from chain rule, then we can move on. So, this is the one. So, this case is slightly difficult when compared to the earlier cases which we have solved, and can you guess the reason why? And the reason is because here we have this term x square plus 2x plus 1 in an e power x function, and that whole thing is once again in sine function, right. So, a function inside a function inside a function. So, we have one extra step which we have to perform, right. So, the idea is the same as earlier, the only thing is that we need to create one extra chain, right. So, dy by dx, what I am going to do now is, I know the idea. So, the outermost function is sine. So, first I will differentiate this without worrying about what is inside. Whatever is inside, I am not going to worry about that, I will just use it as it is. What is the derivative of sine of whatever is present there? I can write it as cos of whatever is present there, e power x square plus 2x plus 1. Now, we should not stop here, because when do we get this? I get this when I differentiate sine of whatever is present there with respect to whatever is present there. Now, what should I do? I need to differentiate this with respect to x. So, I need to differentiate this expression with respect to x. Now, we have again a problem. What is the problem? I know how to differentiate e power x square plus 2x plus 1 with respect to x square plus 2x plus 1, right. So, what I will do is I will differentiate this with respect to this. What will I get? E power x square plus 2x plus 1 is what I will get, right. Now, is the job over? No, because I differentiated this not with x, I differentiated this with respect to this, that is why I got this. Do you understand that? Now, what should I do? I have to go inside this function once again. I have to go inside this function and this is what I get. Now, I have to differentiate that, and when I do that, I would be getting what is the derivative of x square plus 2x plus 1? So, I will get 2x plus 2, clear. So, maybe I have directly showed you, maybe you might feel it is little bit difficult. So, once again, if you feel it is difficult, you can use the smiley method once again, clear. So, what I can do is I can think that this whole thing is smiley. So, when I do that, I will get y is equal to sine smiley, right. Okay. Now, if you look at smiley, smiley is nothing but e power what? X square plus 2x plus 1. So, what I will do is I will assume that this x square plus 2x plus 1 is some other expression. So, let us call it as frowny. Okay, let us call it as frowny. This is smiley, this is frowny. So, it is frowning, it is sad, right. Okay. So, okay, now we need to differentiate it, right. So, what I am going to do is dy by dx is equal to, first I am going to differentiate y with respect to smiley, right. So, I will get dy by d smiley, but I need to cancel this d smiley. So, what I will do? I will differentiate smiley. Now, smiley is a function of frowny, right. So, d smiley by d frowny, you understand that, into, now I need to cancel this frowny. So, what I will do? I will differentiate that frowny finally with respect to x, because we know that we have considered that the value of that frowny is equal to x square plus 2x plus 1. So, if you observe carefully, what I have done is I have divided this function into 3 different basic functions. This is one basic function, this is one basic function, and this is one basic function, that is it. And we are going to now differentiate them, take the product of those 3 derivatives, and what we will be left with is this and this gets cancelled. So, there is a chain which is created here which gets cancelled, there is a chain which is created here which gets cancelled, right, and we will be left with dy by dx. So, now you know how to differentiate this. When you differentiate sine of smiley with respect to smiley, you get cos smiley, which is what I have written here. Observe carefully. Now, if you differentiate smiley, which is this, with respect to frowny, which is e power frowny. So, what is the differentiation of e power frowny with respect to frowny? That would be e power frowny. So, that is what I have written here, clear. Then last part, now I should differentiate frowny with respect to x. So, this is our frowny, so this is our frowny. When I differentiate this with respect to x, what will I get? That is what I have written here. You understand that? So, what I am saying is you can initially understand it by writing in steps like this, right, and then you can substitute the values individually, break down the function into basic functions and substitute the values, or try to practice in directly writing this expression, clear. So, I am telling you once again, so this 3 basic function scenario is not that important for us in physics, clear. So, this is just for your understanding. If you want, you can skip that also, you will anyways learn that in your second year of mathematics, but practice the 2 function cases very much, clear. You will need to do a lot of practice in that. You should be very sure about how to do that, and once you get enough confidence on that, you can try such cases, clear everyone. So, students, the next concept we will be discussing is called second order derivative, right. So, it is called as second order derivative. Okay. So, let us see what it is. So, we will take an example to understand that. So, let us say there is a function y which is f of x which is given by some x power 5 minus 3x square plus 2x plus 13. So, let us say we have a function like this, clear. So, it is given like that. So, now you know how to find the derivative of that function, right. So, if I ask you what is the value of dy by dx, you will quickly write it, right, you can easily write it. So, you know that this can also be represented as y dash, this can also be represented as f dash of x, right. So, let us first write that expression. So, what do I get when I differentiate this expression? X power 5, shall I directly write? I think by now you should be able to do that. X power 5, the derivative is 5 into x power 5 minus 1, 4, right, minus 3 into derivative of x square is 2x, correct. 2 comes to the front, power decreases by 1. So, 2x will be the derivative of x square. So, 3 into 2x is 6x. So, minus 6x. Now, differentiation of 2x, if I write the 2 first, differentiation of x is 1. So, just 2 and derivative of 13 is 0 because it is a constant. Okay. So, now when I differentiated this function, I got another function, right. I have told you earlier the slope of a function, the derivative of a function is again a function which gives you the values of slope of this function for different values of x, correct. What does f dash of x represent? It represents the slope of f of x for different values of x, right. So, that is the idea. So, now second order derivative basically means the derivative of this once again, right. So, that is the name, that is the reason why we call it as second order. So, the next we are going to differentiate this slope again, right. So, we represent that as y double dash. So, this is called y dash. Second order derivative is called y double dash. It double dash means we are differentiating twice, is equal to, this can also be called as f double dash of x, and this can also be represented as, so this is what we are doing now is we are differentiating, we are performing d by dx of dy by dx, correct. We already have dy by dx. What we are doing now? We are differentiating, we are taking the derivative of dy by dx once again. So, this is what we are going to calculate, right, d by dx of dy by dx, and this has a representation. The representation which we use for that is d square y by dx square, clear. So, that is how we should represent it. So, whenever you look at something written in this form d square y by dx square, then you should understand that they are asking you to calculate the second order derivative of y, which means you have to differentiate y twice. Is that clear? D square y by dx square, or sometimes it is also called d2y by dx square, right, d2y or d square y, it is up to you, you can call it anyways, but it should be written in this form d power 2 y by dx power 2. Is that clear everyone? So, this is what we mean by second order derivative, and you know how to calculate that. The idea is just differentiating this again, right. When I differentiate this again, what do I get? So, let us write it down. 5 into derivative of x power 4 is 4 into x power 4 minus 1, 3, minus 6 into derivative of x is 1. So, just 6, and derivative of 2 is 0. So, that is it. So, the final expression which I get is 20x cube, clear, and 20x cube minus 6. So, that will be the value of y double dash. So, this is y dash, this is y double dash. So, for us in physics, we will be using till second order derivative. You can define any order derivative, clear. In maths you will be requiring many orders of derivative, but for us till here it is enough, right. So, even if you are asked to find the next order derivative, for example, if they ask you what is y triple dash, now you know what to do. What will be the value of y triple dash? This means derivative of y double dash. What is the derivative of this? You can quickly write that would be 20 into differentiation of x cube. What is that? 3 into x power 3 minus 1, right, and derivative of this is 0. So, 3 minus 1 is 2. So, this is the value we get, which is 60x square, correct. So, that would be third order derivative and so on. You can differentiate this for any order which they ask you for, but as I told you, till here it is enough for us, and the representation is this. Please keep this in mind, d square y by dx square, right, y double dash f double dash of x, d square y by dx square, all are same. Okay. So, that is the idea of second order derivative. Okay. Now, let us understand what we mean by an increasing function and decreasing function. Increasing and decreasing functions. So, as the name suggests, you know that increasing function basically means a function which is whose output value is increasing as I increase my input. So, that is what we mean by an increasing function. So, for example, if I take a function which is like this, so some random function, let us say it is like this. So, as you can see in this function, at this value of x, so if I am increasing the value of x from here to here, if you look at the output, so right. So, if you look at the output, for this input, this is the output, for this input, this is the output, correct. You can see that from the graph. So, which means as x is increasing, y is also increasing, correct. So, that such type of functions are what we call as increasing functions. A function could be increasing as well as decreasing at different regions. So, what I have drawn here is a continuously increasing function. So, for any value of x, you can see that as I increase the value of x, y is increasing all the time. So, you can see that from the graph. You can take everywhere, anywhere. You can also increase from this value to this value. So, if you draw one more line, so the value of y is definitely greater than the value of y here, correct. So, that is what we mean by an increasing function. So, this is basically a continuously increasing function, continuously increasing function. Okay. Now, there could be some functions like this. So, for example, you have this function y is equal to x square, which you all know, the basic parabola, right. So, if the function is like this, so what can we say about this function? Is this increasing all the time? No, you can clearly see that on this side, as I increase the value of x, let us say here this is my input, for this input this will be the output of that function, correct. Now, as I change the value of this, as I increase the value of x from this to this, you understand that if I am moving to right, I am increasing x, correct. So, as I increase the value of x, look at what happens to y. So, y becomes this, which means y is decreasing, right. So, here the function is decreasing, but from here the function is increasing once again, clear. So, did you understand on what basis can we say a function is increasing or decreasing? On what basis can we decide? So, look closely what I am doing. Here the function is decreasing and here the function is increasing. So, have you noticed that wherever the function is decreasing, if I draw a tangent, what is the angle that it is making with the x axis, positive x axis? Obtuse, right, which means the slope is negative. In the same manner, if I go to the position where the function is increasing, So, here the function is increasing. So, when the function is increasing, so the angle that it makes with the positive x axis is acute, which means the slope is positive, right. So, that is how we decide whether a function is increasing or decreasing. So, what we can do is we can say that slope decides whether a function is increasing or decreasing. Clear, students? And wherever the slope is 0, it is neither increasing nor decreasing. There it is not changing basically. Wherever the slope of a function is 0, there the function is not changing. Wherever the slope is positive, the function is increasing. Wherever the slope is negative, it is decreasing. So, now you can understand why this function is a continuously increasing function. You can see wherever you take, here the slope is like this, again it decreased, again it decreased. So, it is just changing its value, but the tangent is always making an acute angle. You understand that? So, that is the idea. So, whenever you need to decide whether a particular function is increasing function or a decreasing function, just look at its derivative. Why am I saying derivative? Because slope means derivative, slope means f dash of x, correct, dy by dx. So, if you need to understand whether a function given to you is an increasing function or decreasing function, just look at y dash. Clear? If y dash is positive, we can say that it is an increasing function, and if y dash is negative, we can say that it is a decreasing function, and if y dash is 0, right, then we can say that it is not changing. Clear, students? So, that is the idea. You can also understand this in this manner. We know that y dash is nothing but dy by dx or delta y. We should not write it as delta y, but you can understand that as delta y by delta x when delta x is very small, right. It is nothing but change, right. This is change in x and change in y for small values of changes. So, think of it like this. When will y dash be negative? Let us take a scenario where y dash is negative. So, for y dash to be negative, let us say I am keeping dx as positive, which means I am increasing x. So, I am increasing x. Okay. If I am increasing x, dx is positive because dx means what? Change in x, final x minus initial x. So, when I increase x, this is positive, right. When this is positive, how can this become negative? Only when dy is negative. And when is dy negative? When y decreases. You understand what I am saying? So, basically if I fix the value of or the sign of dx as positive, so I am only increasing x, okay. I am always increasing x. When I am increasing x, dx is always positive. So, can I say whatever is the sign of dy will also be the sign of y dash, correct, which means if slope is positive, y is increasing, if slope is negative, y is decreasing. So, that is how we are getting this result. Clear? So, slope decides whether y is increasing or decreasing. So, if y is positive, if y dash is positive, then y is increasing. If y dash is negative, y is decreasing. So, this is a very important thing which you will have to keep in mind. So, please go through this once again. I will repeat once again. If we have a function y, right. So, if you have to check whether y is increasing or decreasing, so just look at its derivative. So, if its derivative is positive, then y is increasing. If its derivative is negative, y is decreasing. If its derivative is 0, y is not changing. Clear, students? So, that is the basic idea. You can say here, for example, if I mark 2 points or 3 points here, let us say, so this is point A, this is point B, and this is point C. So, can you tell me out of points A, B and C, what is happening to the function? Increasing, decreasing and not changing. You can clearly observe that in this particular scenario, if I consider A, at A the slope is negative, so decreasing, and at B the slope is 0, right. If I draw a tangent at B, the slope is 0. So, at B it is not changing, and if you look at C, at C this position the slope is positive, right. So, it is increasing. So, y is equal to x square graph is decreasing at A, not changing at B, and increasing at C. Clear? So, please remember, the first order derivative of a function tells us whether the function is increasing or decreasing. So, I want you to write down this statement in your notes. The first order derivative of a function decides whether a function is increasing or decreasing. Clear?